I'm Nguyen Dao Tuan Anh. This is my MST 400 Project 1 submission as a multiple region website deployment with global load distribution. Let me open the Blackboard and show you my unique IP. Here's my unique IP is 18. So let me switch to other puzzle. Here's my lab account. So I confirm this entirely my own work. I walk you through my PowerPoint, then do a live demo and finish with my reflection. Next, let me walk you through the project scenario. I have developed a company website across two other regions, Canada Central and Spain Central. To ensure the high availability and optimal performance, the solution automatically route users to the closest region, distribute traffic evenly across servers using round robin, and fail over to the backup region if one goes down. Our test VM in South Africa validates the geographic routing. Let's move to the project architecture. Here's my solution architecture. At the bottom, we have two users. The first one is local computer in Toronto. The second one is test VM in South Africa North. Both sending request to as a traffic manager. We sit at the center using performance routing. Traffic manager evaluate latency and route its user to the closest region. My local computer get direct to region 1, Canada Central using VNet 1R1. The South Africa VM get direct to region 2, Spain Central, using VNet R-R2. Inside each region, a load balancer LB-R1 and LB-R2 distribute traffic across to IIS web server using round robin. So Canada has web server 1 and web server 2. Spain has web server 1 and web server 2. If the entire if an entire region goes down, traffic manager automatically reroute everyone to the surviving region. Next is network design and IP address plan. My assigned IP space is 192.168.18.0/24. I split into 3/26 blocks, one per VNet per region. Each VNet has a /28 subnet giving 11 usable hosts. So you can see my VNet-R1 use doc0 start from doc0, and my VNet-R2 start from doc64. My VNet-R3 start from 128. So in Azure, start 28 subnet has a 16 total IP addresses, but only 11 are usable because Azure automatically reserves 5 addresses in every subnet. Those 5 are the network address, the default gateway, 2 addresses used internally for Azure DNS and services, and the final address in the range for broadcast, leaving 11 addresses available for VMs and audio. Let's move to the resources deployed. I have successfully deployed 5 VM in total, 2 for web server in Canada Central, 2 for web server in Spain Central, 1 Windows 11 for test client in South Africa North. Next is Traffic Manager. Why Traffic Manager with performance routing? I choose Traffic Manager with performance routing. It works at the DNS level. When a user makes a request, it reserves to the endpoint with the lowest latency from their location. So Toronto go Canada, Canada Central, South Africa go to Spain Central. If a region fail health check, traffic automatically reroute to the surviving region. That's how I get both proximity-based routing and failover in one service. For configuration, I set routing method with performance, endpoint, Canada low latency public IP plus Spain low latency public IP, health monitor, HTTP port ID, path interval 10 seconds. Full verified domain name is my Seneca ID .tmp .trafficmanager.net. This is the configuration of my load balancer. Each region had a standard public load balancer on layer 4, backend pool, with 2 IIS web server per region. The vertical setting is season persistent, set to none. This is what enables round robin. Without it, the same client would always hit the same VM, and you would never see the traffic alternate. The health probe check TCP port ID for 5 seconds. So this is my load balancer for region 1. And this is my load balancer rules for region 1. This is for my region 2. Next is the demo nearest region routing. This slide is my test results. Let me quickly walk you through the result and then I prove it live. First, you can see my local computer. it will route to Canada Central, and South Africa VMs route to the Spain Central. Now I'm going to switch to my browser and Azure portal. Let me first show you my traffic manager in Azure portal. So here's my traffic manager raw file. You can see the routing method is performing. Let me check the endpoint. So both endpoints are online. Canada and Spain are healthy. Now let me test for my local computer. Let me type the full qualified domain name. It's showing the web page region Canada Central server. So I'm in Toronto, so the traffic manager correctly route me to the closest region, Canada Central. Now let me test in my test VM in South Africa, not with the same qualified domain name. Now I'm on my test VM in South Africa, not. Let me type the full qualified domain name. So and it's showing the Spain Central, the different region than my local computer, because from South Africa, Spain is geographically closer than Canada. This role, my traffic manager performance routing is directing its user to the nearest region. Next is the demo round robin load balancing. This is like so my test results. Let me quickly walk you through the result and then I'll prove it live. Alternates between web server 1 and web server 2 in Canada Central. When I keep refreshing, you can see the result here, the different color and different name, web server 1 and web server 2. And same round robin behavior confirmed like Canada Central. In Spain Central, it keep alternating between web server 1 and web server 2. You can see the result. You can see the difference between the color and the name web server 1 and web server 2. So let me go to the live demo. Now I'll demonstrate round robin. I'm going to refresh the exactly same browser tab, just F5 on the same tab. What's the VM name and background color change? So as you can see now, I'm in the Canada Server 1 blue background. So, and then if I keep refreshing, it's so Canada's web server 2 with a green background now. That's 10 refreshes in the same tab, and the load balancer is clearly alternating between both Canada server. Round robin is working. Now let's do the same test from South Africa VM. Let me go to the test client VM, same tab, just refreshing. Now I'm in the test client VM. So let me click refresh. So as you can see, it's keep refreshing between web server 1 and web server 2. So the round robin is working in Spain as well. Both regions have even traffic distribution. Now let me go to the final demo, global availability failover. This slide is so my test results. Let me quickly walk you through the result and then approve it live. Step 1, stop bot Canada VM. Step 2, navigate to qualified domain name from local PC. Step 3, now serve from the Spain Central. Traffic Manager detected the failure and fail over automatically. Zero downtime, zero manual intervention. Now let's go to a live demo. Now the critical test. What's happened if the entire region goes down? I already stopped it. Bot web server in Canada Central. In the real scenario, this simulates a full regional outage. Bot server in Canada Central are going offline. Traffic manager help proof should detect this and reroute. So both VM are now fully stopped. Let me flush my DNS cache to make sure I'm not getting a cache response. So it's successfully flushed. Now let me go back to my browser and try the same full qualified domain name. So and look, I'm now being sub as Spain Central in web server 2. I'm still in Toronto, but Canada is completely down, so the traffic manager automatically fell over to Spain. The website is still available with zero manual intervention. That's global availability. Finally, is my reflection. For my reflection, I'll cover my personal experience, what I learned, and challenges I faced. For the personal experience, this way, my first time building a multiple region deployment from scratch, setting up the individual pieces, the VM, the load balancers, the traffic manager. Each one makes sense on its own. Seeing them all work together as a system was really where it was really it clicked for me when I refreshed the browser and saw the page switching between web server 1 and web server 2. That's what the moment it felt real. As well actually controlling how traffic moves across the internet. So what I learned, the biggest takeaway is that high availability isn't just about having backup, it's about having redundancy at every layer. Inside a region, the load balancer provides redundancy across VMs, across region. Traffic manager provides redundancy across geographies, and performance routing means user always get the best appearance without any manual configuration. I also learned how important the small settings are. Something as simple as season persistent being set to none versus client IP completely change how the load balancer behaves. I also gain hands-on experience with my IP subnetting across multiple VNet, IIS web server configuration, and how DNS-based routing work at a global level. For the challenge, the biggest challenge I faced were round robin not working initially. Getting round robin to visibly work. When I first set up the load balancer, I was refreshing the page, but it kept seeing the same VM. It turned out season persistent was set to the client IP by default. Once I changed it to none, the round robin behavior appeared immediately. It taught me that the load balancing isn't just about having multiple backends. The distribution algorithm matter just as much. And that's everything for project 1. Thank you for watching.